now realizing should probably be up here. My name is Michael LaBrot. It's L-A, capital B-R-O-T. I hope they're okay. And I'm the founder of Gemini Consulting Group. We've been consulting for nearly 20 years now in the Chicagoland area. Been medium-sized, growth-oriented companies achieve their IT goals. And my current client where I get to practice a lot of this is STA Group. You've probably seen them on the signs, etc. There's a bunch of us running around in this conference. And what I'm going to talk today is how, as a developer, I've learned to buy into this notion that testing isn't something that I have to do because somebody's telling me to meet some kind of requirement, but that testing is actually good for me. It's good for the product. It's good for the overall health of the organization, the maintainability of the code, if you're doing it right. This link right here, which I'll give you a minute to write down if you want, but it's also on the last slide, is the link to the presentation out on OneDrive, so you can grab the PowerPoint and the code examples that I've thrown together for this presentation. It's on the website. All right. Unit testing. This is mostly what I believe Uncle Bob was talking about. Unit testing, we want to ensure that every single little class that we're throwing into our code base, throw some unit tests around that, make sure that individually it's doing exactly what we expect. And the tools nowadays, the JUnits, the NUnits that we have available to us, and the fact that these unit test frameworks are built into the IDEs, I believe prompted him to make this statement. I do believe that is true myself, that if you haven't built this level of testing around the code that you're producing, that it is irresponsible that you would leave that level of risk open in your code base. But what are we really talking about? For a given unit test, the standard term, the generic term is a system under test. For our purposes, since we are .NET, we'll talk about a class, or a .NET class would be the class under test. And that class is going to call out to other classes, and those other classes, we would label those as dependencies. So this class, like I call into this class would call out to another class and another class. But I want to focus what I'm testing just to that system under test. So unit test is going to hit system under test, and we're going to hopefully be able to create a mock or maybe a spy against those dependencies so that we can capture this information and actually test and validate the behavior through actual capturing of the evidence. The term dependency injection is how we get these dependencies injected into that system under test. There are various .NET frameworks for this. AutoFac would be like the Cadillac of dependency injection. A nice simple one would be from Microsoft Patterson Practices, their Unity, which is unfortunately the same name as their 3D game engine. So it's a little weird to Google. Sorry, Bing, sorry. But these dependency injection frameworks allow you to instead of injecting the real dependency class in here, you get to create your own secret version of that mock and inject that into that system under test. Mockito, sorry, that's the Java equivalent. Mock, MOQ, would be an example of .NET mocking framework that I've used. And when we're testing anything in general, and I'll expand this out to larger scope later, but right now, there's the 3 A's of testing. I don't know if you've heard that term, 3 A's of testing. Arrange, act, and assert. Arrange, let me set everything up. And maybe this has to do with just as simple as, I'm going to have to send some parameters into that method call. Let me arrange that, the data for maybe the class height, bean height, is going to go in there. So arrange it, but then act. So now I'm actually calling that method. And after it's all done, I'm going to assert the evidence that I captured to try to prove that the behavior I intended is actually there. The newer terms in behavioral-driven development circles are given, when, and then, but it's the same notion. Given I arrange this stuff, when I act, then I can assert that these things are true. And in this dependency injection system under test universe, the blue stuff is the stuff that I can actually arrange. Like the preparation of your mocks that you then inject into the class will be part of your arranging, your preparation for your acting. After you've acted, you should be able to assert of things in red. So we're used to getting a result back from our method call, or for instance, if we passed in an object, maybe that object was modified or updated. We get that back, right? The return values. Those are easy to grab. It just came back to us. But we also have the ability to grab all of the calls to all of these mock dependencies and examine all of the data that was passed in those calls. And if you're going to go all the way to the edge of this, you can also verify the order in which those calls were made through a mocking framework. And through that, you can see everything that this system under test is going to do or pass onto the other parts of the system. You have all of the evidence you need to assert that it's behaving the way you expect. If there's code inside of here that you can't prove through capturing evidence out here or in the calls to its dependencies, why would you want behavior inside of a class that shows no evidence outside of the class? It might as well not exist. It is dead code. You might be spinning CPU cycles on it, but if it doesn't interact with the rest of your overall system, it's dead code. So, if you are looking at a code base and you're having trouble unit testing it, or you need to start and you haven't before, you may be faced with a certain amount of refactoring that you have to do. But I would recommend that you limit it to one, that you would alter things so that they're more testable, but only in the case of getting dependency injection in there. And potentially, if you have a really huge class, you might need to start thinking about breaking it into smaller classes so that you have more of those edges along the call and the dependency calls to capture and examine that evidence. But in general, you shouldn't have to write code that you wouldn't otherwise want to write. That you shouldn't want to create a bastardized version of your production code just to suit the test. I would recommend avoiding writing weird code just to try to wedge a certain test framework into the mix. And something that is that you absolutely, I would recommend not doing, is cracking open that system under test in order to make some of the private methods inside of that class, make them public or protected so that you can somehow get in and test that that private method was called, or test that private method in isolation. That is a private method. It's not. That system under test should be treated as a black box. And as soon as you start breaking it open just for the sake of trying to get into a particular private method, or you're asking the question to yourself, how do I know the private method was called, right? We're verifying that this other dependency was called. How do I know the private method was called? You don't care. As my point. That's behavior inside of that system. It's not interesting. And the minute you start going down that road is the minute that you start building a unit test code base that starts to become really brittle and really difficult to maintain. Oh, I already said that. So coverage. Let's talk a little bit about coverage. How many people know what coverage means? Okay. It's about 2/3 of the audience. The Java world is I think a little further along in their acceptance of code coverage. They've been doing it longer, but in the .NET world, open cover is available. I'll show you an example of that. .cover, I think, from JetBrains. There's a number of commercial products, but the idea is that it will instrument your code, probably at the bytecode level, and when you run your suite of unit tests, it will remember which lines inside of your production code actually got run. And what's great about that is if any of the lines that didn't get run by your unit tests, you probably forgot to write a unit test. So that's good. What's bad about coverage is that management loves to look at these sorts of numbers, and what they don't necessarily understand is that just because the line said it ran, the only thing it's proving is that you acted. Nothing about coverage tools tell you if you asserted a thing. And if you don't assert, then you're not measuring, you're not proving anything. And I've walked into some code bases where management had seen this tool, they started dictating that certain metrics be met, and the development community would build a bunch of unit tests that got those metrics up. But they didn't assert anything. That's a whole lot of essentially dead and brittle code that you have to now maintain that's not adding any value whatsoever. Because tests are more than just testing your system. Tests are actually an expression of your intent of how that system is supposed to operate. So instead of writing tests to make management happy and hit metrics, start writing your tests to say, look, I want this class to behave this certain way. How do I write a test that will actually prove the behavior I'm intending? And if you start writing your tests with that and only that in mind, and you start treating those tests as first-class citizen along with their production code, if those tests are written cleanly, those tests are written in a maintainable fashion, just like the production code, that it's all production code, then you will stop fighting against your unit test suite. It will stop being brittle. It will stop being albatross and anchor around your neck, and it will start actually adding value that it was all originally intended to have. When I started writing unit tests, I eventually evolved to a point where I was using this when-should pattern before I started getting affected by BDD, behavioral-driven development. And this is fairly similar to the notion of when and then. I would argue that then means then something else happened, or then this should have happened. So then and should, then should. Given when should. But it's sexier to say given when. Anyway, so I started building them this way. So you think about a normal unit test, you get an opportunity way up top to do some top level setup stuff. That would be your given. But then the test itself is really causing the code to happen. This is your act. So this is the when portion, and it's about causing that one method to get called. And you don't want to act. You don't want to act multiple times. You want one act per test. But once you've done that one act, you can assert a goodly number of things. And part of making your tests maintainable would be to say, look, I have an expectation that 8 different things should have happened and I can break them down into actual methods that examine those 8 different behaviors. And then guess what? I can reuse a lot of those same private methods in a second test where I tweak something else about this input. And then maybe the 7 of those things are still true, but the 8th is a not. It should not have done that. And that way I get a lot of modular reads for my unit tests, and they stay a little easier to read. And maybe the most important thing to point out is that I've written really long method names for my tests, and they express the intent of what I'm trying to prove in my production code base. Go ahead and be expressive. That expression of intent is maybe the biggest thing I can say out loud to this audience. Express your intent. Because the expression of intent will increase your confidence in refactoring your code base. I can now, given this, if I have a nicely covered production code base and I know that I need to add another feature into it, I can go over here and I can twiddle something. And I can rerun all my tests. I may have said that I may have some tests that are associated. Maybe I'm doing TDD, we'll get to that in a minute, where I've touched the test that I think I need to touch in order to alter my expression of the expected behavior, and now I run the system and everything's still green. That means I didn't mess something up over here. It's a huge level of confidence that you get. You feel much more enabled to just start going in and making improvements in your code base, especially if the improvements you're trying to make shouldn't alter any behavior whatsoever, right? And all those tests stay the same. You can go in and clean this stuff up, run your tests again, it's still green, you know you did your job. And you can be reasonably assured that you didn't cause some new unintended behavior. And this should have a little bit of a caveat. If I have this level of expressive tests, those tests actually are an expression of how the system should behave as a whole, and they're probably more readable as an expression of intent, an expression of how it should work than the actual code is. And given that level of testing, it's entirely possible that the test would be more valuable if you had to accidentally lose one or the other. Code coverage. All right, I already talked about code coverage and how it is both useful. Obviously, anything that will help me identify a test I forgot to write is a good thing, but slightly dangerous when given into the hands of management who like to look at pretty numbers. Please do leverage a code coverage tool. OpenCover is freely available. It will help you find those tests. Go ahead and let management see your numbers. I mean, you want to be proud of good numbers, obviously, but make sure they understand that this isn't be all end all, and that it only should be used to help you find missing tests, not to beat the team over the head. Mutation coverage. So who's here has heard of mutation testing? A couple, 2, 3 people. Okay. So this is where Java has a huge advantage. Java has an open source tool called PIT, and you can read about it at pitest.org. The concept of mutation testing is you instrument your code probably through the same sort of mechanism as the coverage, so now you know when lines get hit. And then, and all the tests run green, right? That's like the baseline. Now, go in and grab a given line of code. Let's say it's a method call. Remove it. Run your tests again. Something should fail. Something should fail. If nothing fails, if none of those unit tests fail, you have no unit test that proved that that method call was made. And what's great about that is it actually proved to you that something was not asserted, right? That actually proves not the act like coverage does, that proves the assertion. which is huge. It's a hugely more important tool. Unfortunately, as far as I can tell, there's no good automated tool for mutation testing in .NET. There are some examples in blogs. The concept of mutation testing has been around since the 70s. But as you can imagine, changing one line of code, rerunning all of your unit tests, and then going and changing a different line of code, rerunning all of your unit tests, it's rather expensive. And a lot of the solutions that I've seen in blogs have to do with manipulation of the actual source code, like doing weird regexy type of manipulation and then recompiling. So now you have to change a line of code and recompile and rerun all your unit tests. So it's really an onerous process, but keep that in the back of your mind, and maybe somebody in the audience here can start thinking about building us a good open source, freely available mutation test framework for .NET. That would be lovely. Right, both of them about identifying. Find the test that you forgot to write. If you're expressing intent, you forgot to express that intent. All right, test-driven development. Now that I've said all of that, now that everybody in this room is totally bought into this notion that you should unit test your stuff, and those unit tests should express intent. Now that you're expressing intent, why don't you take a minute to write a unit test that expresses the intent of the behavior that you're about to add to the system. I know it's going to fail. The behavior doesn't exist yet. But now that you've got that test, you can easily launch right into that class and build the behavior, and when you get that test to run green, you know you're done. And now you've got a test, and you got the production code, and it's all green, and you check it in, and everybody's happy. And your coverage is still up. This is test-driven development. You write the test first. And some would argue that TDD actually stands for test-driven design, because you took that minute to think before you wrote your production code, to think about it enough to say, well, I know I want to add this behavior, but how would I prove that it's actually what I wanted? So how do you practice TDD? Uncle Bob has these three very simple rules, right? Don't write your production code until you've got your test that proves it doesn't exist. And then you don't write, and this is a big thing, and this is where people get tripped up. You don't write unit tests for your whole system. We're not asking you to do that. We're asking you to write one little tiny test, and you only write enough of a test to make it fail. And then you go and write just enough production code to make that test good. And then you can write your next test for your next little piece of behavior. Make it go green. And the verbal cycle is called red to green refactor, because in between those things, now that your tests are green, if there's something that maybe you left in the production code that was a little dirty or messy, now is the time to go in and tweak that code, make it a little cleaner, make it a little better, not add behavior, just clean it up. Just refactor and clean it up a little, and your unit test will still stay green, because now you've got that confidence of the green test suite. So that's TDD. One fun way to practice this is, how many people in here are actually pair programming? It feels like it's a myth, right? We've all tried it or thought about it, but it's kind of a myth. But if you can maybe carve out an hour a week even to play this game with one of your fellow teammates, sit down at a computer together. One guy will write the test that goes red, and then hand the keyboard over to the other guy. The other guy makes that test go green, and then he gets to write the next test, hand the keyboard back to the first guy, and he gets to make that test go green. So and really brings both of you into the moment and into a paired expression of intent and execution of that intent. And it really sort of helps drive home the actual practice. It helps you get better at doing this when you're not paired with somebody. All right. One of the biggest reasons why I think I've walked into code bases, and those code bases have been a monolithic mountain of brittle, unmaintainable, and useless unit tests, is a simple reaction, human nature reaction to a waterfall type of development effort. That we as developers are really happy to exist in this space. But then testing, since it's a delayed concern, we tend to leave that stuff towards the end. And especially if you're getting like right here in the project and your manager starts looking at your coverage numbers like, you need to spin those numbers up and they're like, oh crap, let me go write a bunch of unit tests because I haven't been doing it all along. And now you're not spending the time to express intent. You probably don't even necessarily know or aren't familiar with the class that you're writing a test for because you've just been told to write this test. And so it seems to me that it's a really good, it's not good at all, good's the wrong word, explainable reason why I've seen code bases fall into that hole. Simply as an artifact of waterfall. In Agile, however, testing is a first-class citizen, and some would argue that you're waterfalling, but at least you're only doing it in the span of a 2-week sprint. But an Agile team includes tester, should include a tester. And between the tester and the product owner and the developers, at least one, that's like the holy trinity of concerns. And between all three of them, if they're all working together, you're going to be able to produce what's wanted in a quality fashion, and all of your checks and balances are met. The three branches of government, if you will. And at the end of the sprint, since you've delivered an actual deliverable product at the end of the sprint, the acceptance testing of that product should be implied. It's implicit to this process. So at least if you're practicing Agile, or hopefully if you're pretending to practice Agile, you'll have these testing built into that framework and into that subject. Now the test pyramid. We've mostly been talking about unit tests down here. There's also a notion of acceptance tests, and we have tools available to us now that we didn't used to have. Before that make this a lot better. Selenium, for instance, has really evolved over the past few years to be from being sort of a curiosity to being actually helpful. Integration tests and acceptance tests, they're hitting your system from the outside. So like SoapUI is a great tool for hitting web services, Selenium for UIs. And if you're expressing the intent of the system as a whole, right? It's sort of the same diagram. Think of the whole deployable system as your system under test in these acceptance tests. If they're expressing intent, especially if they're expressing the intent of the business, what they want. Those would happen at this level. Integration tests are sort of somewhere in between. I'm going to gather together smaller or bigger portions of my system. It's not exactly what I would deploy, but let's say I'm writing a UI, and rather than doing just the class under test, maybe I want to grab the controller and all the things the controller calls, but I'm not going to like deploy it behind an actual website so that I can hit it from the outside. I'm just going to call into it through a .NET method call, that controller, with all of its dependencies intact. That's more of an integration test. The reason this is a pyramid is because we've got a bajillion little classes running around in our system, and therefore we should have a bajillion little tests running around in the system. And so you've got a lot of these, like 60% of your tests are in that space. Integration tests, to a lesser extent. I actually, some say this should be maybe 20-30% of your testing. I don't know. your mileage may vary. It depends on how weird your system is put together or how much value you think you can get. If you can get a lot of value out of that, by all means, please do it. But I'm a huge fan of this up here. But the problem is you don't want to write like Selenium tests. They're essentially interacting with your HTML off the server. You don't want to be writing tests like that. They're really expensive to run. And so you want to write a lot of them. You're not going to have nearly as many. You don't want to be going after a test that says, on this drop down, I've got this value and this value and this value, right? And under this other circumstance, that drop down has a slightly altered list. I mean, if you're trying to cause these tests to be hitting the system at the sort of same granularity as unit tests, you're gonna kill yourself. It's way too much work. It's way too difficult to keep those up. But if you can define some big coarse-grained intended behavior at this level, especially if you can match that up from a traceability standpoint back to use cases or business capabilities from your BA product owners, then they can see how what they were asking for interacts with your system, and it also ends up being a live documentation, again, of your intended behavior of the system, as opposed to writing it into a document and then letting it sit on a shared drive for 3 months and then forgetting about it. That thing got stale the day after you put it out there. These actually will tell everybody exactly what the system is doing right now. So this is what I was talking about, where let's say this is your controller. So your unit, like, still use NUnit for this to call into your controller, but then these are not. These are the actual things that you would normally be doing. And you get that integration between components. And then you acceptance testing. Right, expressions of customer request. And so we talked about acceptance test-driven development. Well, that now can be expanded out to this concept of acceptance test-driven development. So before you start adding a feature to the system, you can write that acceptance test and sit down with your tester, the product owner, and a couple of developers, and you actually talk about, okay, well, you're asking us to add this new behavior into the system. How are we going to be able to prove that we've done that? And get that written. And you don't even necessarily need to build that specific behavior right away. You can just you can express it in the form of that failing test. There's actually, I'll show you later, a way to flag that test as pending. Like this isn't failing, it's not broken, we just haven't gotten to it yet. But then management can actually see all the features they asked for in your progression through a list of those coarse-grained features. And this new term, behavior-driven development, again, sort of the same notion where let's express that behavior, and well, let's see if we can do it in such a way that it actually makes sense to the business people, as opposed to unit testing where maybe you're going after you're at a low level. It's an esoteric distinction. Business people aren't going to understand that. But in acceptance test and BDE, you're actually trying to come to some agreement and express what they're asking for in language that they can understand. And this Gherkin language is born out of this behavior-driven development movement. Cucumber, actually, SpecFlow, I think, is the official Cucumber implementation for the .NET universe, and it uses this Gherkin language. I don't know what Gherkin stands for, just Cucumber Gherkin. And here we see the given, when, and then. And this all looks great until you realize that this is actual executable code. This is the code that you've written for your test. How do we do that? Well, I'll show you. But that the business people will see this, and they'll see this in the reports, and they'll be able to understand and read it. And then under the covers, you can plug these expressions. And there's a regular expression mapping into actual executable testing code, and you can drive it all through your normal NUnit type frameworks, and produce those reports that actually have meaning back to the business. All right. Continuous delivery. Another way. Before I get to this slide, let me actually say it out loud that all the things that I've been talking about so far, especially in that Agile slide I should have mentioned, all of this really does have to do with how developers are being pulled harder into the actual testing of the system. Right? Back in the waterfall days, we postponed that, and we were only responsible for the unit tests, and then we only did those at the end. But now with Agile and all these better tools that are available to us, that's how this stuff is starting to infect our lives, and how we can't just pretend it's somebody else's concern, it's actually our concern. Continuous delivery is another example of how this, another movement, how this is being pushed into the development realm, because in continuous delivery, I check in a line of code, a job will detect that something's polling the code base and says, oh, somebody's changed the code, let me go automatically compile it. Now that it's automatically compiled, maybe I'll run some testing, the unit test suite against it, and if that's good, then I'm going to actually deploy that onto some running servers, and now maybe I can hit it with Selenium or SoapUI tests or other automated test frameworks and see it actually behaving the way I want in a running system. And now that I have that running, I mean, you could stop there, but if you're Spotify, you go even further, and it gets deployed into production. Continuous delivery all the way to production. I mean, somebody in Spotify, you should go find these videos. They check in a line of code, 15 minutes later, their new feature is spun up and running in production. So given that kind of a model, given that kind of ideal pipeline for delivery, and continuously available access to those new features from the business, obviously testing and making sure that what we just did is reasonably sane becomes part of that overall continuous delivery process. And you would not want to be checking code in that doesn't have a certain level of sane testing around it. So some takeaways. Start simple, right? Don't, just like TDD in general, we're not asking you to go and refactor your entire code base. You can start practicing TDD right now, right after this session. Maybe you don't have any unit tests at all, but you can write a unit test for what you're about to write. And over time, every line of code that you add or change, if you write that test first, eventually you'll start having a reasonably safe and deep level of tests, set of tests. Have somebody in the organization that is, it can't just be you. I mean, it can, TDD can be you, but overall, this notion of let's get some automated testing around it, let's start building these more healthy practices, let's actually start expressing intent in the tests instead of leaving it until the last minute. You need some buy-in from your management, from the people around you, the product owners and the BAs and the testing organization. Start fostering that grassroots support for trying to keep this stuff green. If you do have a test that is broken, I know that you really want to get this behavior into the system, but you don't. The longer you leave those tests red and broken, the harder it's going to be to bring it back to green. Because who knows how much additional refactoring is going to be necessary in order to get them back to green. Plus, you've been working over here, you broke something over there, you don't know what the impact of having broken that over there might be on the rest of the system once you do get back to thinking about this concern, and you might realize that you've just spent a day and a half building the new stuff over here that just isn't going to work because you forgot about what that really meant over here. It sort of goes back to the whole broken windows notion. Like the building is reasonably secure and it's not dilapidated, but assuming that that building is no longer occupied, right? As soon as somebody breaks the first window, it's going to be days before somebody breaks the rest of the windows, right? Same sort of motion. There is a certain amount of time, obviously, that you would spend. I would argue that if you're really practicing safe TDD, you can go faster. But perception-wise, people are going to say, you're wasting a lot of time trying to build this testing around your system because it's hard to measure how much time you're going to spend in the future tracking down bugs that exist or other painful things at the end of your project. So I understand it's a difficult sell, but it's an important sell. And yes, I can't tell you the number of times I've found something that just did not occur to me because I had a unit test written for it. And everything that I'm talking about so far is actually real world stuff that I'm actually practicing every day. How much time I got?
6 minutes.
Say again?
6 minutes.
6 minutes? All right, let me show you some real world stuff. So here we have back to our talks on dependency injection. Here we have a reference app from the Patterns and Practices Unity guys, where they threw together the stop-light implementation, and they have built dependency injection into their stuff, and through the built some nice tests, not exactly my when, should, but they're actually expressing those unit tests in terms of, hey, it should be doing this, it should be doing that, so expression intent, so that's good. And then run open cover against it. So you can see, even though they wrote some nice tests around and showed how you can use dependency injection to isolate those classes on your test, in this reference app, they haven't exactly hit all those metrics. There's a lot of red. It might alarm management. Just let you know. So in the zip file that I put on OneDrive, this whole project is out there for you to poke around inside of, including a back file for the execution of open cover. And then other solution. I threw together some Selenium stuff. Well, we take a look at this conclusion slide. And Graham, probably the biggest thing that I can give away to you all is that your test should express intent. If they're not expressing intent, then you're just doing it because somebody told you to do it, and it's going to be brittle, it's going to be broken, and it's going to be unanchored. And it'll do the exact opposite. It will provide drag rather than lift. Because once you express intent, you promote the factoring, provides a living documentation of the system, how it should work, modern tools, like Selenium, open cover, the SOAP UI, mock, a number of tools, right? These are all out there now to help us. There's no good excuse for how hard it is anymore. A lot of these things are available and easy to do. All right, so here is an actual test. Wingtip Toys is another web reference app out. Viewers. And I was able to build this gherkin test against it. And this executable code actually gets this feature. Here's the test. So here's an example of how that expression of that gherkin language maps into the executable code. And in here, I'm using this Internet Explorer driver through Selenium.net to actually interact with this running web page. Which is essentially just a simple book. So if we look at this driver code and say, hey, go to the site. So given that I visit the toy site, I should be able to see that the title of that page is Welcome Wingtip Toys and And then when I open my shopping cart, so if I jump into the cart, it's empty, so that cart should be empty. So there's that expression of that gherkin language. And hopefully you can see how, for us, we care about this bit, but management, they like that other file. And to have this actually show up as being the code that we see. I want to actually run this to show you that it's real. Unfortunately, we have to launch this at the command line so that Visual Studio have it as its launcher of the test. Selenium launched ID. While we wait for that, do we have any questions?
What's your recommended code coverage percentage?
Recommended code coverage percent. That's actually a really astute question. 90, maybe even 95, 100 is 100. Somewhere in there, there's a line that you cross where you're trying too hard. And if you're trying too hard, then you start thinking about altering your code in order to make the unit tests better metrics when you've started to cause your actual production code to become less maintainable just to get your test metrics right. So 90, 95, not 100. I mean, 100 is possible. If you get to 100 without heroic effort, right? But if somebody's telling you you have to be at 100, tell them to get bad. That's insane. You should not have to go to heroic efforts. you should not have to lessen the quality of your production code in order to get that. There are ways for a lot of these tools, like OpenCover has a rather robust filtering mechanism. And so if there are things that shouldn't be tested, then you would tell OpenCover, look, I fully intend not to cover this class. Like I've created a facade maybe over around some static calls or otherwise really untestable crud that I got from a third party. So that class, his entire purpose in life maybe is to just wrap that thing so that I can have this wrapper be my injected dependency, and I can mock calls to that wrapper, but the actual calls to that third party stuff is hidden. And then this class that is nothing but a facade for it, don't bother trying to cover that. Don't measure it intentionally. And that should be allowed. Hey, look, I've got unit tests and they actually express something. I think I'm out of time. Yeah?